My name is Samantha Carpenter. I am a senior engineering student at Oklahoma State University working with Dr. Ford Resip and in collaboration with Dr. Swindle Riley. Our research focuses on modeling controlled release of pharmaceuticals through bilayered microspheres. Millions of Americans have been diagnosed with eye diseases affecting various structures in the eye. These diseases are usually treated with an intravitreal injection, an injection into the eye. These injections often require frequent trips to the physician's office and cause the patient pain. With this in mind, the focus of our research is to provide a reliable model to predict cumulative drug release through microspheres that can be applied in the treatment of eye diseases. The microsphere we modeled in MATLAB was a bilayered symmetrical sphere with an inner layer of chitosan and an outer layer of PCL mesh. This structure was directly studied by Dr. Swindle Riley's team. The experimental data gathered from their study, as shown in the graph below, shows the difference between a bilayered chitosan and a PCL sphere and a monolayered chitosan sphere and their drug release profiles. You can see that the bilayered sphere had a reduced burst percentage and a steady release over the next 5 months. In our model, we used a symmetric sphere with variable diffusion coefficients with an analytical solution you can see at the top. This solution shows the release of drug Q with respect to time is integrated over a non-dimensional radius 0 to 1. We then utilize the method of lines to approximate variable diffusivity of the two layers through spatially discretized ODEs. We then, using the data provided by Dr. Swindle Riley, estimated our parameters through nonlinear least squares to find the diffusion coefficients in centimeters squared per second and the burst percentage. These parameters were then put into our model and used to estimate the effect of different diffusion coefficients for the PCL layer. As you can see at the top, the smaller the PCL diffusion coefficient, the higher the cumulative release over the same time. For the diffusion through the microspheres over the total radius, the concentration remains steady until it reaches the space between the chitosan and PCL layers, showing that most of the diffusion control occurs in the PCL layer. Looking forward, we would like to investigate other types of microsphere injections and apply this model to different microstructure geometry, like the cylindrical capsule. Ultimately, we would like to produce and distribute a reliable and predictable open source model.